Problem 14-030-104. Find the sum S equals 1 times 2 plus 2 times 3 plus 3 times 4, and so on, up to 100 times 101. Reference: Singapore Mathematical Olympiad, Sample Questions, 2025. Solution: we solve this problem in 4 ways and then generalize it.
Method 1. Notice that each term is written as k times k plus 1 equals k squared plus k, for k equals 1, 2, and so on, up to 100. Thus, the sum becomes S equals the sum of k squared from 1 to 100, plus the sum of k from 1 to 100. The sum of the first 100 positive integers is sum of k equals n times n plus 1 divided by 2, where n is 100. That is, 100 times 101 divided by 2 equals 5050. The sum of the squares of the first 100 positive integers is sum of k squared equals n times n plus 1 times 2n plus 1 divided by 6, where n is 100. That is, 100 times 101 times 201 divided by 6, which equals 338,350. Therefore, combining the two sums, we have S equals 338,350 plus 5,050, which is 343,400.
Method 2. Observe the following. 1 times 2 equals 2, which is 1 times 2 times 3 divided by 3. 1 times 2 plus 2 times 3 equals 8, which is 2 times 3 times 4 divided by 3. 1 times 2 plus 2 times 3 plus 3 times 4 equals 20, which is 3 times 4 times 5 divided by 3. 1 times 2 plus 2 times 3 plus 3 times 4 plus 4 times 5 equals 40, which is 4 times 5 times 6 divided by 3. We guess that 1 times 2 plus 2 times 3 plus 3 times 4, and so on, up to n times n plus 1 equals n times n plus 1 times n plus 2 divided by 3. We prove this by induction. The statement is true for n equals 1, 2, 3, and 4. Assume it is true for n. Then it is also true for n plus 1 because the sum up to n plus 1 is the sum up to n plus 1 times n plus 2, which equals n times n plus 1 times n plus 2 divided by 3 plus n plus 1 times n plus 2, which simplifies to n plus 1 times n plus 2 times n plus 3 divided by 3. Therefore, the sum equals 100 times 101 times 102 divided by 3, which equals 100 times 101 times 34, giving 343,400. Method 3. Let f of k equal 1 times 2 plus 2 times 3 plus 3 times 4 plus and so on, up to k times k plus 1. Then, f of k plus 1 minus f of k equals quantity k plus 1 times quantity k plus 2. Also, f of 1 equals 2. Now, assume f of k equals a k cubed plus bk squared plus ck plus d. Then, we write the following system of equations. When k equals 1, we get 2 equals a plus b plus c plus d. When k equals 2, we get 8 equals 8 a plus 4b plus 2c plus d. When k equals 3, we get 20 equals 27 a plus 9b plus 3c plus d. When k equals 4, we get 40 equals 64 a plus 16b plus 4c plus d. Now, subtracting the first equation from the others, we obtain d equals 2 minus a minus b minus c. 7 a plus 3b plus c equals 6. 26 a plus 8b plus 2c equals 18. 63 a plus 15b plus 3c equals 38. Solving this system step by step. From the second equation, c equals 6 minus 7 a minus 3b. Substitute into the third equation, 6 a plus c equals 3. This gives us 6 a plus 6 minus 7 a minus 3b equals 3. Rewriting, we find 7 a plus 3b equals 3. From another equation, we also get 21 a plus 3b equals 10. Now, subtract the 2 to solve for a. 21 a plus 3b minus 7 a minus 3b equals 10 minus 3. This simplifies to 14 a equals 7, so a equals 1/3. Substitute a equals 1/3 back. b equals 3 minus 6a, which gives b equals 3 minus 6 times 1/3, so b equals 1. Now, compute c. c equals 6 minus 7 a minus 3b, so c equals 6 minus 7 times 1/3 minus 3 times 1, which equals 2/3. Finally, compute d. d equals 2 minus a minus b minus c, so d equals 2 minus 1/3 minus 1 minus 2/3, which equals 0. Thus, the function f of k is f of k equals 1/3 times quantity k cubed plus 3k squared plus 2k, which simplifies to 1/3 times k plus 1 times k plus 2. Therefore, the final answer is S equals f of 100, which equals 343,400. Method 4. We know that n-1 times n equals 2 times the binomial coefficient n choose 2. Also, n choose 2 is the coefficient of x squared in the expansion of 1 plus x to the power of n. Therefore, the sum is equal to the coefficient of x squared in 2 times the sum of 1 plus x squared plus 1 plus x cubed, and so on, up to 1 plus x to the power of k plus 1. This is equal to 2 times 1 plus x to the power of k plus 2 minus 1 divided by x. The coefficient of x cubed in 2 times 1 plus x to the power of k plus 2 is 2 times the binomial coefficient k plus 2 choose 3. Thus, the sum s equals k times k plus 1 times k plus 2 divided by 3. For k equals 100, s equals 100 times 101 times 102 divided by 3, which is 343,400.
Hint. Here, we unintentionally proved that the sum of binomial coefficients from 2 choose 2 up to n choose 2 equals n plus 1 choose 3. In general, if 1 is less than or equal to k and k is less than or equal to n, then the sum of binomial coefficients from k choose k up to n choose k equals n plus 1 choose k plus 1. For example, the sum of terms like 1 times 2 times 3 plus 2 times 3 times 4, and so on, up to n times n plus 1 times n plus 2 equals 6 times n plus 3 choose 4, which is n times n plus 1 times n plus 2 times n plus 3 divided by 4. If you liked this video, please like it. I would appreciate it if you subscribe to the channel for more videos.